Hello everybody, welcome to your Ticket to Reteach video for topic 2. All right, so we are gonna do some reteach to build understanding in lesson 2.1, dealing with parallel lines. So use the diagrams to fill in the blanks, determine whether the pair of angles are congruent or supplementary, and find the measure of the angle. So this is just a good review of our vocab. So first we have parallel lines cut by a transversal. 4 examples of that. Same side interior angles. Angles 1 and 2 are same side interior. If you notice, they are on the inside of our parallel lines, so that's where the interior comes from, and they're on the same side as the transversal. So same side interior angles will be supplementary. I actually want so one thing that's not on here, let's just add in another picture. I was going to say, let's talk about same side exterior, and it's just not there. So we'll draw an extra picture up here. If you have parallel lines cut by a transversal, same side exterior angles could look like angle 1, angle 2. You can see they are on the exterior of your parallel lines. They're outside of your parallel lines, but they are on the same side of your transversal. So those are same side exterior. Same side exterior angles will be supplementary. So what I wanted to point out was it's all the S's. Same side interior angles are supplementary. Same side exterior angles are supplementary. So that's just one way to remember that. All right, next we have alternate interior angles. So parallel lines cut by a transversal, they are interior because they're on the inside of your parallel lines, on the interior of that, but they're on alternate sides of your transversal. So angle 1 is on this side, angle 2 is on this side. Alternate interior angles will be congruent. Corresponding angles, parallel lines cut by transversal. Um, Angle 1 and angle 2 are corresponding because they're in the same position. So I can see angle 1 is the top right angle of this grouping. Angle 2 is the top right angle. When you have corresponding angles, those angles will be congruent. And then our last pair of angles are alternate exterior angles. So parallel lines cut by a transversal. These are exterior angles 1 and 2 because they're on the outside of your parallel lines, and alternate because they are on alternate sides of your transversal. Alternate exterior angles will be congruent. So remember, the only angle pairs that are supplementary are your same sides. Same side interior, same side exterior. The other 3 angle pairs will be congruent. So if angle 1 is 100 degrees, angle 2, well, since we know that they are supplementary, they have to add up to 180. So if angle 1 is 100 degrees, angle 2 must be 80 degrees. Just 180 minus the 100 gets us to that 80 degree. If angle 1 is 75 degrees, and these angles are congruent, angle 2 must be 75 degrees. If angle 1 is 82 and you have corresponding angles, angle 2 will be 82 degrees because they're congruent. If angle 1 is 77, angle 2 is going to be the same measure, 77 degrees, because those are alternate exterior angles. Okay, a student said that the measure of angle 1 equals 80 degrees. What error did the student likely make? What is the measure of angle 1? So we've got parallel lines cut by a transversal. We have this angle and this angle. So what angle pair is that? They're on the interior of your parallel lines, and they are on the alternate sides of the transversal. So those are alternate interior angles. And what we just talked about up above, the alternate interior angles are congruent. What this student did is they thought they would be supplementary. If this is 100, they said that's 80 degrees because 100 plus 80 is 180. But alternate interior angles are not supplementary, they are congruent. So the measure of angle 1 is going to be 100 degrees. All right, let's move on to lesson 2.2. It says match each figure with the statement that proves that line L is parallel to line M. So if you are starting with congruent angles or supplementary angles, then you can conclude that the lines are parallel. These are our converse theorems. So in this first example right here, we're given that angle 1 is congruent to angle 4. So what angle pair is 1 and 4? Those are in the same position. They correspond to each other. So those are corresponding angles. So it's the converse of the corresponding angles theorem that would tell us that L is parallel to M. So that one's going to match up with that. Our next example, we have angles 3 and 5. These are interior angles, and they're on the same side of our transversal. So if your same side interior angles are supplementary, that means that you have parallel lines. That's the converse of the same side interior angles postulate. All right, here we have angle 1 and angle 6, and we're given that angle 1 is congruent to angle 6. So what angle pair is this? They're exterior angles outside of your parallel lines, and they are on alternate sides of your transversal. So if you're given alternate interior angles as congruent, you can conclude that therefore you have parallel lines, and that's the converse of the alternate exterior angles theorem. Okay, so we've got another student that said when x equals 6, A is parallel to B. What error did the student likely make? And then for what value of x is A parallel to B? So let's just plug in a 6 and see what angle measures we got here. So 5 times 6 plus 12. 5 times 6 is 30. 30 plus 12 is 42. So if they are, well, they said x equals 6, so they're getting this angle measure to be 42 degrees. And then 7 times 6 is 42 degrees. So they are saying that these two angle measures are congruent to each other. Do we agree with that? What angle pair is this? So they are interior angles inside our possible parallel lines, and they're on the same side of the transversal. So those are same side interior angles. Are same side interior angles congruent? No. So what the student did is they said that they were congruent. They started out with the equation 5x plus 12 equals 7x. They solved and got x equal to 6 and thought that meant you had parallel lines. But same side interior angles are supplementary. So what that student should have done is taken 5x plus 12 plus the other angle 7x and set it equal to 180. So we can go ahead and do this math. Combine your like terms. 5x plus 7x is 12x. Plus 12 equals 180. Let's subtract that 12. So we have 12x equals 180 minus 12 is 168. Divide both sides by 12, and we get x equal to 14. So x equals to 4, when x equals 14, line A is parallel to line B, because we started with a correct equation identifying that we had same side interior angles. Let's take a look at our 2-3 lesson. This was on parallel lines and triangle angle sums. So we have a triangle. Well, use the diagrams to fill in the blanks. This one's on interior angle measures. We have triangle ABC. So in this lesson, we learned that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So let's fill in our information. We know the measure of angle A is 54. We know the measure, well, we don't know the measure of angle B, which is why we're going to leave that as measure of angle B. And we know the measure of angle C is 48. So we can go ahead and simplify 54 plus 48. We get 102. So angle B plus 102 degrees equals 180. And then to get the measure of angle B, we'll just subtract 102 from both sides. So 180 minus 102 is, 78 degrees. So we're able to work with our triangle angle sum because we know that the three interior angles of a triangle will add up to 180 degrees. We also learned about the exterior angle measure. So here, what the exterior angle theorem, I think it was called, the exterior angle theorem, the measure of angle DCA. So let's make sure we understand where that is, D to C to A. We are looking at this angle right here. The measure of that angle is equal to the measure of angle A plus the measure of angle B. So these are the remote interior angles. They will add up to equal the opposite exterior angle. I'm just saying opposite so we understand it's across the triangle, and it's an angle, it's an exterior angle created by extending one side of your triangle. So let's go ahead and fill in these statements. The measure of angle DCA is equal to the measure of angle A, we know to be 59. The measure of angle B is 40. And we're just going to add 59 plus 40 together. And we get 99 degrees for the measure of angle DCA. All right, so from the figure shown, Abby concludes that the measure of angle 1 is 85 degrees. What is Abby's error? How would you correct the error? So first of all, let's just figure out what we think the measure of angle 1 is. Angle 1 is an exterior angle, so we know it's equal to the opposite remote sum of the remote interior angles. So the measure of angle 1 is equal to 62 plus 33. 62 plus 33 is 95 degrees. So this angle measure is 95 degrees. Abby got 85 degrees. So how do you think Abby got 85 degrees? So what she likely did, angle 2 is actually 85 degrees. I know that angle 1 and angle 2 will add up to 180. So 95 plus 85 is 180. But what I think Abby did is she just worked with her interior angles. I think she added up 62 plus 33 and subtracted it from 180 and got 85 degrees, but thought that was angle 1 out here. So that's the mistake I think she made. Complete the sentences to find the value of x. The measure of the exterior, where's my pen? There we go. Angle, so the measure of the exterior angle of the triangle equals the sum of the measures of its two remote interior angles. So our exterior angle is 117 degrees. So the 117 degree angle equals the sum of the 29 degree angle and the x degree angle. So here's our exterior angle. It's going to equal the sum of 29 plus x. It's opposite remote interior angles. If we look at that just off on the side as an equation, we're saying that 117 is equal to 29 plus x. To solve for x, we would subtract 29 from both sides. And here's what they're asking us to fill in next. So the x degree angle is because we subtracted, it's the difference of the 117 degree angle and the 29 degree angle. So there's that 117 minus 29. And when we do that, we get x to equal 88 degrees. So therefore, x equals 88 degrees. All right, our last lesson we worked we looked at or we learned about was our 2-4 lesson, which was on your slopes of parallel and perpendicular lines. So this first question wants us to match each set of lines with the correct statement. The statements are over here in the boxes. So here we have what looks to be parallel lines. Line A is parallel to line B. Here's our notation, A is parallel to B. These two lines appear to be forming a right angle, and we're told line A is perpendicular to line B, and here's that notation, A is perpendicular to B. So what do we have over here? The slope of line A times the slope of line B equals -1. So if you're multiplying your two slopes together and you get -1, that is what happens with perpendicular slopes. So we're talking about our perpendicular lines on that one. Our next statement is the slope of line A equals the slope of line B. So we just want to remember when the slopes are the same, those are your parallel lines. Parallel lines have the same slope. All right, so we're going to fill in the blanks to find the equation of the line perpendicular to y equals 1/3 x minus 2 that goes through the point 1, 4. So the slope of the given line is 1/3. If we look at our equation, the slope is always the value with the x as long as you are solved for y first. Perpendicular lines have slopes with a product of -1. So the slope of the perpendicular line is, so I'm just going to make a notation up here. The perpendicular slope is equal to, we also, another way that we found a perpendicular slope was the opposite reciprocal. So maybe I'll just write that word out, opposite reciprocal. So if you are looking at your slope of 1/3, let's find the opposite reciprocal. That will be the perpendicular slope. What that means, reciprocal, you're going to flip your fraction. So instead of 1/3, it's going to be 3/1, which is just a 3. And then you're going to change the sign. This slope was positive. The perpendicular slope will be negative. So the slope of the perpendicular line is -3. And positive 1/3 times a -3 does equal -1. So their product is -1. To write the equation of the perpendicular line, use the slope-intercept form. To solve for the y-intercept. So here's our y equals mx plus b. I'm going to go ahead and rewrite. We know our perpendicular slope that we're going to use is -3, and they also told us this line is going through the point 1, 4. So when you have that extra point on your line, that's giving you an x and a y that you can plug in to y equals mx plus b. So we're going to replace the y with the y value of our coordinate equals, they already plugged in our slope. So here's our slope. Slope goes right there, times the x value of our coordinate, which is 1. And then we solve this equation for b. So we'll kind of do that off on the side. We have 4 equals -3 times 1 is -3 plus b. And then to get b alone, we will go ahead and add 3 to both sides. So b is equal to a +7. Now we can answer the question. The equation of the line perpendicular to y equals 1/3 x minus 2 passing through the point 1, 4 is y equals, we're going to use our perpendicular slope and our y-intercept that we just found right there. So y equals -3x plus 7. All right, Danielle says that the line perpendicular to y equals 5x plus 9 and passing through the point 3, 4 is y equals 5x minus 11. What is Danielle's error? How would you correct the error? So first thing I want to look at is the slope. The slope of the line they gave us is 5, and Danielle's slope of the line she wrote is 5. So what kind of lines have the same slopes? That would be parallel, but they wanted us to work with perpendicular. So these are not perpendicular slopes. That was her error. The perpendicular slope would be, if you flipped that and changed the sign, it would be a -1/5. So that's how I would correct it. I would write an equation with a slope of -1/5. Okay, now that we have done some reteaching and revisited these concepts, let's go ahead and just run through some practice problems. So use the figure for exercises 1 through 4. So we're going to use this figure right here. Identify all pairs of each type of angle. So here we have two lines cut by a transversal. So clearly these lines are not parallel. So we're not going to have any congruent or supplementary angle pairs, but you still have angle pairs. You still have corresponding angles, same side interior, blah, blah, blah. So let's find our corresponding angles. Corresponding angles will be in the same position. So angle 4 corresponds with, I want to find the same angle in this grouping. So angle 4 is kind of the bottom left angle. So in these angles, the bottom left is angle 8. So angle 4 and angle 8 are corresponding. Angle 1, top left, let's find the top left over here. That will be angle 5. So angle 1 and angle 5 are corresponding. Let's say we start with angle 3. Angle 3 corresponds to angle 7. Bottom right, same angle position. Then our last one, angle 2, will correspond with angle 6. Same side interior angles. So here's our transversal. We want interior angles that are on the same side of the transversal. So interior angles are going to be 2, 5, 3, and 8. And which pairs are on the same side? So angle 2 and angle 5 are on the same side of the transversal, and they are both interior, so those are same side interior angles. We also have angle 3 and angle 8. So these are on the same side of the interior, and in the interior, these are on the same side and interior. Alternate interior, so these are going to be interior angles again, so we're just looking inside our two lines that are cut by the transversal. We want the pairs that are on alternate sides of the transversal. So angle 2 and angle 8 are alternate interior, and angle 3 and angle 5 are alternate interior. So here's 2 and here's 8, up alternate sides of the transversal, angle 3 and angle 5. Alternate exterior, so angles that are on the outside, the exterior of our two lines cut by the transversal. So we're looking at angles 1, 4, 6, 7, and they need to be on alternate sides of the transversal. So angle 1 and angle 7 are both exterior on alternate sides of the transversal. And then angle 4 and angle 6 are alternate exterior angles. Okay, which angles are supplementary to the given angle? So when you have parallel lines cut by transversal, I'm going to go ahead and mark all the angles that are congruent to this 128 degrees. So 128 degrees, the angle opposite it is a vertical angle. Those will be congruent. Angle 5 is corresponding to 128, so those will be congruent angles. And angle 7 is an alternate exterior angle with the 128, so those are congruent. We also could say, if we know 5 is 128, 5 and 7 are vertical, therefore 7 must be 128. So those are our congruent angles. I'm actually going to erase those marks. Sometimes for me, just to do a little, these angles are congruent. The other angles that I did not circle, angle 1, 2, 4, and 6, those are all congruent to each other. And the ones that are supplementary are any combination of one that I circled with one that I did not circle. So what angles are supplementary to this angle 128? So anything I didn't circle will be supplementary. So I didn't circle angle 1, angle 2, angle 4, and angle 6. Those are all supplementary. Because if 128 is circled, anything that's not circled will be supplementary to it. Which angles are congruent to the given angle? So those are going to be anything we circled. We circled all the congruent angles. So angle 3, angle 5, and angle 7. All right. Use the figure for exercises 1 through 4. Using the given information, which lines can conclude are parallel? State the theorem or postulate that justifies each answer. So if we're given that angle 1 is congruent to angle 4, so here's angle 1, here's angle 4, I want to draw the line that connects those. This is your transversal, which means these would be your parallel lines. So I think that S is going to be parallel to T, but what theorem or postulate? So what angle pair is this? These are alternate exterior angles. So if you start with alternate exterior angles being congruent, the theorem is the converse of the alternate exterior angle theorem. That leads us to conclude the lines are parallel. All right, if we know that angle 2 is congruent to angle 3, so let's find angle 2. Here's angle 3. Draw the line that connects those. That is your transversal, which makes these our parallel lines. So I think that D is going to be parallel to E. What's the reason? So what angle pair is that? 2 and 3 are in the same position. Those are corresponding angles. So if your corresponding angles are congruent, you can conclude that lines are parallel by the converse of corresponding angle theorem. Maybe I want to be, let's see, angles, corresponding angle theorem. All right, 6 and 7. Let's find 6 and 7. If 6 is congruent to 7, so here's angle 6, here's angle 7. Again, find the line that connects them. That's your transversal, which means our parallel lines will form the other side of that angle. So I think that D is parallel to E. And how do we know what angle pair is 6 and 7? Those are alternate interior angles. So if you start out with alternate interior angles being congruent, the converse of the alternate interior angles theorem leads us to having parallel lines. And last we have the measure of angle 5 plus the measure of angle 8 is 180. So let's find angle 5 and angle 8. I'm not going to mark them congruent because they're not congruent, but I'm going to mark them so I know which angles we're looking at. I'm going to draw the line that connects those. Those are your transversals, or that's your transversal, which means these must be our parallel lines. So I think that S is parallel to T. And which angle pair is that? Those are interior. They're on the inside of our parallel lines and the same side of our transversal. So remember, same side interior angles are supplementary when you have parallel lines. So if you're given that those angles are supplementary first, then by the converse of same side interior angles, we can conclude that S is parallel to T. Okay, so we're going to run through a bunch of examples here. They're all a little bit different, so we may be applying different theorems to each one, but we're going to find the value of each variable. So in question number 1, here's our variable x. We can see it's an interior angle, and we're given the other two interior angles. So remember, all three angles inside a triangle will add up to 180. So if you take 180 and subtract out the 92 and the 63, oops, x will equal 25 degrees. Example 2, same idea. We've got an interior angle and you know the other two angles inside the triangle. So if you subtract those out of 180, or you could add them up and then subtract that from 180, we are going to get angle X to equal 73 degrees. So I'm kind of saying out loud the work right now. I'm not writing down the work, but on the test, it's always a good idea to write down the work. So in case you end up with a wrong answer, but you had the right idea, that's where partial credit helps you out. So example 3, same idea. 80 plus 40 is 120. Subtract those out of 180, we are getting angle X to be 60 degrees. Okay, let's see if our examples get any more involved. So for this next example, we've got a few things going on. First, I notice we do have a triangle on the left where we know two angles, 28 and 85. So if we subtract those out of 180, we're getting 67 degrees for angle X. So we know that X equals 67 degrees. The next thing I notice is that X is right next to angle Y. So this is a linear pair. These will be supplementary. So if we take 180 and subtract 67, we're going to get angle Y. So angle Y is 113 degrees. Now angle Z is an interior angle. I can see that we actually have the other two interior angles now that we have Y. So if we subtract 15 and 113 out of 180, we get 52 degrees. So Z equals 52. Okay, so our next example, kind of same idea, but I'm going to start with a triangle on the right because we're given two interior angles. To get the third, I know that those would add up to 180. So if we take 180, subtract out 57 and 24, angle Z is equal to 99 degrees. Angle Z and angle Y form a linear pair. They're side by side with the straight line sharing a vertex. So those are supplementary. So if we take 180 and subtract out 99, we're going to get angle Y to be 81 degrees. And now the last thing we need is angle X. We know the other two angles inside this triangle. So we keep using the same theorem where angles inside a triangle add up to 180. If we take 180, subtract out the 81 and the 43, that leaves you with 56 degrees for angle X. All right, so next triangle, exact same process. This is nice and repetitive. So we've got a triangle here where our three angles will add up to 180 and you know two of them. So if you have 180, subtract out the 50 and the 84. That leaves you with angle Z of 46 degrees. Angle Z and angle Y are supplementary. So if we do 180 minus 46, that's going to give us 134 for angle Y. Maybe I should be writing this down. Angle Z is 46 degrees. Angle Y is 134 degrees. And angle X is part of this small triangle where we know one angle is 134, the other one is 11. So subtract those out of 180 and we get 35 degrees. So X equals 35 degrees. All right, that's some good practice. For this next group, let's find the value of X. So like we did, right here, X is an exterior angle. So we have a theorem that says your exterior angle is equal to the sum of the remote interior angles. These are your remote interior angles. So we know that x will equal 38 plus 70. 38 plus 70 is 108 degrees, so x is 108. Number 8, same idea. We've got x as an exterior angle. It's equal to the sum of the remote interior angles. Those remote interior angles are on the opposite side of the triangle. So we know that x equals 39 plus 94. And we're getting 133 degrees for angle x. Number 9, here's our exterior angle. Angle x is going to equal the sum of our remote interior angles, which are 43 and 81. So if we add 43 and 81 together, we're getting 124 degrees for angle x. All right, so this next row, what's different about these? Well, we have an exterior angle, but that's the one we know. So we will set up an equation. It's still going to be the exterior angle equals the sum of the remote interior angles, but this time our exterior angle is known. So we're going to say 81 equals the sum of our remote interior angles, which are 19 degrees, and x. So x plus 19. Then we'll just have a little equation to solve to get our x angle. X is equal to 62 degrees. Number 11, we have our exterior angle. So we know that 115 will be equal to the sum of the remote interior angles. So 41 plus x. And then to find x, just subtract 41 from both sides. And we get 74 degrees. Number 12, same thing. Oh, no, it's not the same thing. It's similar to these up here. We have our exterior angle, which this time is x. That's equal to the sum of the remote interior angles, so 41 plus 36. So we just have to take 41 plus 36 to find the measure of angle x, and we get 77 degrees. All right, so here's kind of a trickier picture, maybe. I'm not sure. Let's see what we think. Find the measure of the given angle. So we need to find angles A, B, and C. We can do this in any order you want, whatever feels easiest. So, like, I notice angle C is inside this triangle, and we know angles 43 and 71. So remember, those angles will add up to 180 degrees. So if I have 180 and I just subtract out the 43 and the 71, that's going to leave me with angle C. So angle C is equal to 152 degrees. Angle B is not inside a triangle. This is an exterior angle. Well, it's actually not quite an exterior angle. So we'll come back to angle B. Let's find angle A. Angle A is inside this triangle. So we know that if we take 33 and 112 away from 180, let's subtract 33 and 112. Angle A is equal to 35 degrees. So originally I assumed angle B would be an exterior angle. An exterior angle is formed when you extend the line of one of your sides of your triangle. So angle B I can see is formed with this line right here, but it's formed with this line, not the other side of the triangle. So the exterior angle to this triangle is actually this combination right here, 71 and B combined. So what I noticed, there's more than one way to actually get this answer, but we have angle B, we have 71, and we have 35, all forming this straight angle, sharing a vertex. So those three angles are going to add up to 180 degrees. That's just our angle addition postulate where smaller angles will add up to the big angle measure. So 35 plus 71, we have 106 plus angle B equals 180. Let's subtract 106 from both sides, and we're getting angle B to equal 74 degrees. And there we have angles A, B, and C. All right, on to our last page of our Ticket to Reteach packet. We're going to work on our parallel and perpendicular lines and writing those equations. So write the equation for the line parallel and the line perpendicular to the given line. So our given line is y equals 2x plus 7. We want to identify the slope of the line they gave us. So this slope is equal to 2. That's slope-intercept form. The slope is the number in front of the x. So a parallel line, we'll do parallel first, is going to use the same slope. So we want to use a slope of 2, but with that ordered pair of 0, 1. Now, one thing is if we notice, hey, this is the y-intercept. If you were to plot the point 0, 1, you would go up 1 on the y-axis and plot your point. So we have the y-intercept. We can just go ahead and write our equation. We're going to plug into y equals mx plus b. So y equals 2x plus 1. It's rare for us to be given the y-intercept. If we recognize it, let's save ourselves a little bit of work. All right, perpendicular. So the perpendicular slope to the line they gave us. So we're going to take this slope of 2. We're going to flip the fraction and change the sign. So it's going to be a negative 1/2. We want to go through that ordered pair 0, 1. We just talked about how that is the y-intercept, so we can plug right into our equation. Y equals negative 1/2 x plus 1. Here's a perpendicular equation. All right, next example, the line they gave us, we want to identify the slope of this line. This slope is a negative 1/3. We want to write an equation of a line parallel to that. So parallel is going to have the same slope. So we're going to use a slope of negative 1/3, but we want to go through the point 3, 5. This is not the y-intercept, so I can't just say that this 5 is my y-intercept. 3, 5 is in the first quadrant somewhere, so that's not where we cross the y-axis. So we have to do a little bit of math this time. We're going to use our y equals mx plus b equation. We have an x and a y. We're going to plug into that, and that will allow us to solve for b, our y-intercept. Once we have the y-intercept with that slope, we'll be able to write our equation. So we're going to replace the y with a 5. Our slope is negative 1/3 times our x is a 3 plus b. So 5 equals negative 1/3 times 3 is a negative 1 plus b. We'll add 1 to both sides, so our b, which is our y-intercept, is 6. So this equation is, I'm going to write it slanted, y equals, our slope is negative 1/3 x plus 6 for our y-intercept. There's our parallel equation. Now perpendicular, I'm just going to use this symbol. I don't feel like writing that word out again. The perpendicular line, so our perpendicular slope, let's take the slope of the line they gave us, negative 1/3, opposite reciprocal. We're going to flip this and change the sign, so we're going to use a slope of 3. Our line is going to go through that ordered pair 3, 5. Again, we don't know the y-intercept. The y-intercept won't be the same as the y-intercept over here because the slopes are different. So it's going to hit the y-axis in a different spot. So let's plug into y equals mx plus b again to find that y-intercept. Here's the x, here's the y we're going to plug in. So we're going to have 5 equals, our slope is 3 times the x value of 3 plus b. 3 times 3 is 9. Let's subtract 9 from both sides. And our y-intercept, our b value, is -4. So the perpendicular equation is y equals, our perpendicular slope was +3. The x goes with that, and then -4 for the y-intercept we found for that equation. All right, we're on a roll. Last problem. So this line they gave us looks a little bit weird, you know, y equals -5x minus 1/2. The only thing we care about from this line is the slope. So the slope is the number with the x. That line has a slope of -5. So even this weird looking y-intercept on the end, I mean, it's not that weird, it's just a -1/2, but that doesn't come into play with what we're doing. Okay, so let's write our parallel equation, a line that's parallel to the line they gave us. So parallel lines have the same slope, so we want to use that same slope of -5, but we want to go through the point -4, 2. Is -4, 2 the y-intercept? It is not. The y-intercept will have a 0 for the x. If you were to plot this in your head, -4, 2 would be in the second quadrant. That is not on the y-axis. So let's plug into y equals mx plus b with our x and y from that ordered pair. So replace the y with a 2. We know the slope is -5. Replace the x with a -4, and then we will work on solving for b. So 2 equals -5 times -4 is +20. We'll subtract 20 from both sides. 2 minus 20 gives us a -18 for our y-intercept. So our equation that is parallel to the line they gave us is y equals, we're going to use that -5 slope. The x goes with that, and then -18, because that's the y-intercept we found for the parallel line. All right, last one, perpendicular. So we want a perpendicular slope. So the line they gave us has a slope of -1/5. Perpendicular to this, we are going to flip this and change the sign. So that's going to turn into a +1/5. Our line is going to go through the point -4, 2. Again, like we said, that -4, 2 is not the y-intercept, so we have to find the y-intercept when we have that slope of 1/5. So let's plug into y equals mx plus b with this x and this y from the ordered pair. So replace the y with a 2 equals, our slope is 1/5 times our x value is -4 plus b. All right, so 2 equals, feel free to use your calculators for this fraction work. That's going to give us a -4/5 plus b. We will solve for b by adding 4/5 to both sides. So our y-intercept is 14/5. So 2 plus 4/5, go ahead and use your calculator. Let's make sure we use the improper fraction of 14/5. So our final answer, the equational line that's perpendicular to the line they gave us, is y equals, our slope is 1/5, the x goes with that, and the y-intercept we found to be a positive, so plus 14/5. All right, so we're on our last part of this review. This is the 9-1 additional practice. I am actually going to say, let's cross those off. I really want to focus on number 9. And so this video is already decently long, so let's just skip to number 9, which I think is better preparation for a test retake. All right, so number 9 says, is triangle ABC a scalene, isosceles, or equilateral triangle? So when I look at the picture, we're going to create triangle ABC. I can just see that we're going to go ahead and connect A to C. And now we can actually see the triangle that we're talking about, A, B, C. So there's triangle ABC. To answer the question if it's scaling, isosceles, or equilateral, we need to know how long all three sides of this triangle are. I would hope for a vertical or horizontal side so I could just count, but every side is slanted in some way. So this is just the distance formula 3 different times. Um, and we will end up using some of our answers to help us with number 10. So we'll get to reuse this work. But um, to start, I'm going to just identify the ordered pairs so that I can plug those into the distance formula pretty quick. So point A is at -6, -1. Point B is at -5, -5. And point C is a -1, -4. All right, so we're going to start by finding the length of each side, starting with AB. So that's the square root of, distance formula is the square root of, in our first parentheses, is x2 minus x1. So I'm just going to subtract the x's from points A and B. So we have -5 minus a -6 turns into +6. That gets squared. Plus, now we're going to subtract our y's. -5 minus a -1 turns into +1. We square that. And then just to save time, I'm just going to type all this into my calculator to figure out. We have the square root of 17. So AB is square root of 17 units long. All right, now we're going to do the same thing for BC. So distance formula is the square root of, we're going to subtract our x's. So we have -1 minus a -5, so +5 squared plus 4 minus a -5, or no, excuse me, -4 minus a -5 turns into +5 squared. And that will give us the square root of 17. So far we have two congruent sides. So it's not scalene. It could be isosceles. We just want to check our third side. Our third side is side AC. Square root of, subtract our x's. Let's see, -1 minus a -6 is +6 squared. Plus now we subtract the y's. -4 minus a -1 turns into +1 squared equals the square root of 34. All right, so AC is the square root of 34. All right, so is this scalene, isosceles, or equilateral? Because we just ended up with two congruent sides, this is an isosceles triangle because there are two congruent sides. All right, we have a follow-up question. So that explains how we know that it's isosceles. Is it a right triangle? So a right triangle will be a triangle that has a right angle. If we look at triangle ABC, we can predict that if there is a right angle, it would be right here at B. It looks the closest to a right angle, and we will just check that to see if it is. If this is a right angle, that means that AB would be perpendicular to BC. So we can check our slopes on that. Do we have perpendicular slopes? So counting the rise of our run from A to B, it's going to have a negative slope. We're going down 1, 2, 3, 4, and we're running to the right 1. So let's see where I want to write that. Let's see, the slope of AB is a -4, and then the slope of BC is, so from B to C, let's see, we want to know if this is going to be perpendicular to that -4. Well, I can see it's a positive slope, so starting on the left, we're rising 1, and we're running 1, 2, 3, 4. So we're rising 1 and running 4, so 1 over 4. These two slopes are opposite reciprocals of each other, so that means that yes, this is a right triangle. All right, last question. Find the area and perimeter of triangle ABC. So the perimeter means just to add your sides together. And we already found our three sides. So that's a square root of 17 plus a square root of 17 plus a square root of 34. And that's equal to about 14.1. So there's our perimeter. Now area has an area formula. Our area formula is 1/2 base times height. Now, since we've already determined that this is a right triangle, our base and our height are going to be the two sides that create that right angle. So BC is the base and AB is the height. So that's what we're going to plug into our area formula. It's 1/2 times the square root of 17 times the square root of 17. And that gives us a total area of 8.5. Maybe I'll throw in a units squared. All right, there you go. Lots of good information to help with a test retake.